Hi everyone, my name is Antje Bart. I work as a developer advocate for Rhine Machine Learning at AWS. In this session, I'm showing you how to build end-to-end machine learning workflows with Kubeflow Pipelines. So let's have a quick look at the agenda. I'm briefly explaining why we're talking about machine learning with containers and on Kubernetes. I'm introducing you to Kubeflow and the Kubeflow Pipelines project. And we're going to see a demo of how to build your first pipeline. And in the second part, I'm also showing how you can scale your machine learning on Kubernetes with Amazon Sagemaker. And we'll see another demo of how you can build a more advanced pipeline integrating also into Amazon Sagemaker. All right, so let's get started. First of all, why are we talking about machine learning with containers? And it's really bringing the same benefits to your machine learning environments as it does to any application development. So think of your projects. You might be using different frameworks. You might be using TensorFlow, PyTorch, MXNet, and they all come with different versions and dependencies. By packaging up your training code with the dependencies and the configurations, you will get machine learning environments which are lightweight, portable, scalable, and consistent with containers. And also, for Kubernetes, you will leverage many of the platform benefits that Kubernetes bring. So for example, the composability. You can develop a component and then reuse it in your machine learning pipelines. Also the portability. You can start developing on-premise or in a development system and then port it to the cloud environment, to your production environment as needed. And scalability. So with Kubernetes will handle the infrastructure scaling to match your application need. And the good news is you don't have to manage Kubernetes all by yourself. You can leverage managed services such as Amazon EKS to run Kubernetes in the cloud. And with that, you will get a fully managed Kubernetes control plane, and you can simply attach your data plane, and you will have the same native upstream Kubernetes experience. Also, you don't have to develop the Docker containers all by yourself. AWS offers deep learning containers, which are pre-packaged Docker containers, fully configured and validated, and already optimized for the best performance and scalability, so you don't have to tune it any further. They're supporting the major frameworks such as TensorFlow, PyTorch, and MXNet. You can run single and multi-node training as well as inference. And they're supported on Amazon SageMaker, on EKS, on ECS, and Amazon EC2. All right, so let's jump into Kubeflow and Kubeflow Pipelines. Kubeflow is an open source project, and you can think of it as the machine learning toolkit for Kubernetes. It actually consists of many different projects, one of which is Jupyter Notebooks. It also comes with a project that helps you to build end-to-end machine learning pipelines, which we will see here in just a second. It also supports model training and model serving, and there's many other projects that are part of Kubeflow. For this session, let's actually focus on building machine learning pipelines as our major use case. And if you're working in this space, you're probably familiar with those pipeline steps. So you will start ingesting your data, and you do have a couple of steps to perform to prepare the data, analyze, transform it, before you can start developing the model, with developing your model training code, validating it, and then training it at scale. So let's see where Kubeflow Pipelines can help us. Kubeflow Pipelines is part of the bigger Kubeflow project. It comes with a user interface which you can use to manage and track your experiments, your individual jobs, and the runs. It also comes with an engine to schedule multi-step machine learning workflows, as you can see here on the right, which shows an example execution graph of a pipeline. And it also comes with a software development kit, which we will use in our notebook in the demo to define the pipelines and the components. So when I talk of components, what does it mean? Basically, a Kubeflow pipeline is constructed of individual pipeline steps. And each step is an execution of a component. The component is implemented as the Docker container, and it contains obviously the code to execute and also any inputs and outputs and the metadata for the specific step. So you're basically lining up those individual steps to define your Kubeflow pipeline. And how do you do that? So first of all, you have to have your code. So let's assume this is your model training.py file. You would then include that in a Docker container image. And you need to convert the Docker container then to an official Kubeflow component, which you can easily do with a Python decorator function, which comes with a domain-specific language of Kubeflow pipelines. Then you develop those components and you combine them in a pipeline, and you can use another decorator function to then convert it into the official Kubeflow pipeline object. And then you can compile it, which will create the YAML definition, and then you can execute by running that YAML on your Kubernetes environment. Here's some sample code that shows how to do that. So again, you start by developing the individual components. You're lining them up as a pipeline definition, and then you're using the decorator functions to create the official pipeline object. You compile it, and you run it on the cluster. So let's actually see this in action. So I'm jumping here into my AWS environment. And as a first step, I've created a Kubernetes cluster. As you can see here, so I do have EKS running. I do have my demo cluster. And in the next step, I installed Kubeflow on top of this Kubernetes installation. So think of Kubeflow as just another application that is running on top of Kubernetes. And here you can see the dashboard, the UI. And on the left, the individual components. So for example, pipelines, the notebook servers, Katib, which is hyperparameter tuning, and the artifact store. All right, so the first step is to go into the notebook servers. And here I created my Jupyter Notebook environment. I can connect to it and then run my sample code. And here you can see our first Kubeflow pipeline. And what we're going to do here in this demo is creating a very simple first Kubeflow pipeline. The first step we need to do here is to install Kubeflow pipelines. And you can see this is a very simple pip install. And I'm also making sure to pick up the newly installed libraries by doing a quick kernel restart. And then we can start defining our first pipeline. In this example, what I'm going to do is really just adding up two numbers. So I'm creating the sum of two numbers and then adding a couple of more steps to see how you can build a 4-step pipeline. Once we have the code, and I'm going to show you how to create that code, we're going to wrap it in a container image. And I'm going to use a very simple Docker container image for that purpose. All right, so let's see how we do this. First of all, the code I write as a Python function, and then I'm also pointing it to a Docker container image. So let's start. So let's import our Kubeflow pipelines. Let's import the domain-specific language. And then I'm starting to create my code. So here you can see the Python function, add two numbers, A and B, which is returning a container op, which is the object for the Kubeflow component. I'm giving it a name, so I'm calling it calculateSum. And I'm pointing it to a very simple Python Docker image. I'm running a Python command. And what I'm doing here is basically creating the sum of numbers A and B, and I'm writing it to a text file as my output. All right, so let's add another step. Let's do an echo. So here I'm creating my echo component again, calling it echo, and using even a simpler bash image to execute it. And I'm really just running the echo command and reading in the results from my text file. All right, so we're almost ready to go. So let's create the pipeline. And here you can see that I'm starting by defining the pipeline object with a domain-specific Python decorator. I'm calling my pipeline calculate_sum, so I'm creating this Python function here. And I'm passing in hard-coded for values A, B, C, D. And let's create a 4-step pipeline here. So the first step is to add the numbers A and B. Then I'm adding up C and D. Then I'm adding those two results together. And as a final step, I'm calling the echo to show the result. All right, so the next step is to compile the pipeline. So on KFP compiler, I just call compile, give it the name, that's my calculate_sum pipeline. And what you can see here is it will create a zip file. And we can actually have a look into that zip. And you will see that it contains the pipeline.yaml file. And if we look into the pipeline YAML, you will see that it contains all of the code that we just defined. So our pipeline definition got converted now into YAML code. All right, and with that, we can actually deploy it on our Kubernetes cluster. So using the KFP client, I'm first of all creating an experiment, which is really just grouping my experiments together. So let's call it Kubeflow. And then I'm calling the run pipeline, passing in my experiment ID that I just created, and the name of the pipeline calculate_sum. All right, and that fires up the pipeline on my EKS cluster. So let's have a look at the dashboard here. And I'm back in the UI from Kubeflow in pipelines, and I'm opening up my calculate_sum. And you can see here the 4 steps that got executed. And you can click into each of those steps and you can see the inputs and the output parameters for the first step, for the second step. And then the third one basically sums up those 2 results into the final one, which is here in this case, 28. And remember, each of those components is an individual Docker container. And the echo step here, if you click on logs, shows the final resulting 28. All right, so this was really a very first simple introduction on how you can get started building your Kubeflow pipeline. Maybe you want to combine the open source do-it-yourself with innovations from AWS. And here is a blog post which I highly recommend to read, which shows all of the contributions that AWS provided to Kubeflow to integrate with the AWS services, in particular around security and scaling your AI and machine learning with the help of Amazon SageMaker. And let's see how we can do this. So here's a quick overview of the AWS machine learning stack. And Amazon SageMaker is the service that helps you to build, train, and deploy machine learning models quickly by abstracting a lot of the infrastructure for you. So let's see how we can integrate this and how we can scale machine learning on Kubernetes with the help of the integration into SageMaker. AWS contributed and developed specific components for Kubeflow pipelines called the Amazon SageMaker components. And you can leverage those components to build customized steps in your Kubeflow pipeline, integrating, for example, with SageMaker model training, with hyperparameter optimizations, the processing jobs, and many more. So let's see how we can do this. And here I'm jumping back into my demo environment again. So I'm in my AWS account, in my Kubeflow installation. And in this example, I'll show you how you can build a more sophisticated Kubeflow pipeline. And we're also integrating some of the steps with Amazon SageMaker. And the use case here is as follows. I want to build a machine learning model which classifies text based on the sentiment. And I'm going to use a public data set, the Amazon customer reviews, which consists of 150 million reviews from the Amazon.com marketplace. And what I'm going to train the model on is to read the reviews, the customer product reviews, and classify them into the corresponding star rating. So for example, if I say, I really love this product, I want the model to return me a 5 or a 5-star rating, etc. And I'm going to do this the following. So I'm going to use a pre-trained BERT model. And BERT is a very popular natural language processing model, basically a whole family of models. And the good news is you don't have to train them from scratch. So I'm going to leverage a pre-trained model from the open source Hugging Face library. And what I need to do is do the feature engineering. So I'm going to integrate with Amazon SageMaker processing jobs to run the feature engineering. And in particular, I'm going to take the raw text inputs and I'm going to convert it to the BERT embeddings, which the model is expecting as an input. And my code is written in TensorFlow. So what I do as another step is also to convert those embeddings into TF record files. And then finally, we're going to deploy the model. All right, so here you can see how we can get started. So first of all, I'm pulling in a couple of dependencies. I'm going to install SageMaker SDK, Kubeflow Pipelines, the AWS CLI to integrate with the AWS services, and again, doing a quick kernel restart. Then I'm also setting some environment variables. So I'm pulling in Boto3, the Python SDK for AWS services. And I'm specifying my account ID, the S3 bucket to use, and the execution role. And then the first step here is really to get our training data. So the Amazon customer reviews are shared in a public S3 bucket, which is this one. And what I'm doing here is basically I'm copying 3 categories of reviews down from the public bucket into my private bucket. And I'm using the categories of digital software, digital video games, and digital ebooks. So those are the 3 categories that contain the reviews, which I'm going to train the model on. And you can see the files come in TSV format, which is tab separated. All right, so making note of where to find the input data. And let's start building the pipeline. So again, I'm importing Kubeflow Pipelines. I'm importing the components, the domain-specific language, and also the AWS extensions. Then, as a next step, as I said, I want to integrate some of those steps of my pipeline with Amazon SageMaker. In particular, the processing step, the training, the model, and the model deployment. So what I'm going to do is I'm downloading here those components from the public URLs. One for the processing step, one for the model training, one for creating the model, and then for deploying the model with SageMaker. And you can see here, those are public GitHub URLs where you can find and then download those component YAML files. All right, so the first step in the pipeline will be to pre-process our data. And again, it starts with having your code ready. So here you can see my pre-processing Python script. And what I'm doing in here is, as I'm using the Hugging Face pre-trained BERT model, you can also leverage a tokenizer that comes with it. So I'm pulling down the distill BERT, that's the version of BERT I'm using, tokenizer. I'm setting the data label columns, and then I'm developing my pre-processing code. So for example, one step is to convert the raw text into tokens, and then I'm creating the BERT embeddings, which the model is expecting. And I'm also converting it to the TF record format. All right. So what I have to do is to upload my Python script to an S3 bucket so SageMaker can access it. And I'm doing the exact same thing here with my training code. So here's my model training code. And again, this is just the regular training code I would execute. So I'm pulling in some libraries which I need, again, here from Hugging Face. And I'm parsing the data and the label from the records. I'm setting up some helper code to read in file-based inputs. And then I'm basically starting to develop my model here. Decoding records, checking if there is a checkpoint of the model to load, and then parsing the hyperparameters, etc. Everything I need to build up my model. All right, so let's zip all of those code files together and upload them again to my S3 bucket. Then I'm also defining some additional helper code here to give me the processing input in the format that Sagemaker is expecting it. So here one is to define the inputs and one is to define processing outputs. And then I'm also doing a little helper function here to give me the exact same format for the model training inputs for Sagemaker. All right, and that was a little bit of preparation, and now we can start defining our pipeline. So again, I'm starting here with the decorator function on top to basically convert the following pipeline function into an official pipeline. Let's call it the bird pipeline, pass in the role, our bucket, the region information, and where to find our raw text. Then I need to define the Docker images for the steps, right? So here I'm using the pre-built images for processing, training, and serving. So those are the AWS deep learning containers for the specific framework version. I'm giving the pipeline a name. And now I'm preparing this first feature engineering step. So here I'm just setting a couple of parameters. For example, the maximum sequence length, which is a variable for bird. Also the training, validation, test data split percentage. I'm balancing the data. And I'm pointing here to the buckets where to store the processed data. I'm also specifying the instance count where to execute this processing and the instance count. So I'm doing 2 instances here of that type. And then I can define the first component. So here's my Sagemaker process up, passing in all of the parameters which we just prepared. Also passing in those parameters as container arguments, the train split, etc. And then my entry point in the container is my pre-processing script. Here I'm making use of those input configurations. So I'm passing in the configuration where to find the code and the data, and also to define the outputs where to store the processed data files. All right, let's move to training. So in the training step, again, I need to define a couple of parameters. So one is where to find my data. So those are the training data channels. And a couple of hyperparameters for my model. So here you can see I'm just defining a few of them. I'm specifying again my instance type and count. Where to store the output. So this will contain my model tar file in a bit. Then I'm building up the dictionary here of my hyperparameters. And I'm also making sure to keep track of metrics from Cloudwatch. So for example, the training loss and accuracy or the validation loss and accuracy. And then I can build this component step, Sagemaker train up, which contains again all of those variables. So I here pass in everything that we just constructed. And then I'm almost ready. So the last 2 steps are to create the model from the fine-tuned model tar file, which we will receive. Also specifying on which instance type to deploy it. And then the final step here is to create the endpoint and to deploy our model into production. All right, so this was a little bit more complex pipeline. So 2 more steps here. So first of all, we're compiling it again to get our YAML file. And you can see here it's creating the bird pipeline zip. And again, we can have a quick look into that and we can see the YAML file. And again, in here, you can see all of the inputs being converted now into a YAML definition. And the next step then is really to take the YAML file and to create the experiment. Let's just put it in the same Kubeflow group and run the pipeline. And then let's see how that pipeline looks. So let's click here on the experiment, which takes us back to Kubeflow. And here you can see the bird pipeline and our execution graph. I've run this before, as it takes approximately 20-30 minutes for all the steps together to pre-process and train. And here you can see now the results. So for the processing step, you can see all of the inputs and the outputs that we specified. And let's actually have a look at the outputs, which are the processed data files put into 3 buckets for training, validation, and test data. So if I flip over here to my S3 bucket, you can see the outputs being generated. So let's click into processing, into outputs, and here you can see the 3 folders. So we have test, train, and validation data. And if you look into that, here we go. So here you have the TF record files that contain the BERT embeddings. All right, and the next step was the model training. So again, if you click here on this component, you can see the inputs and the outputs. And let's grab this training job name, and let's actually see if that ran on Sagemaker. So I'm flipping here to Amazon Sagemaker, and I can see my training job. It ran on Sagemaker, and here you can see all of the, again, configuration that we specified, the inputs and the outputs. And the model training completed, so there should be a model tar file. Let's actually check our S3 bucket. And I'm clicking here into the output for my training job. And here we go. So here you can see our model.tar file. All right, so 2 more steps. So the third one was to create our model object from the tar file. And then the last step here was to deploy the model as an endpoint as well, integrating with Amazon Sagemaker. So let's grab the endpoint name. And again, I'm going over to my Sagemaker environment, click on endpoints, and here we can see our endpoint. It's ready and in serving. And if you click in here, you can see this URL, and you can embed this into your applications to call this API to serve your predictions. All right, so let's actually see how we can predict with the endpoint. So I'm switching back into my notebook code, and let's make a prediction to see if the model is actually working. So I'm using my Boater 3 SDK to pull in a Sagemaker runtime object. I've also noted down the name of this endpoint. Here it is. And then I can just pass in a sample review. Let's say, this is great. And I'm passing in this review text to my endpoint. And once I'm parsing here the result, I can see that my model predicted a star rating of 5. All right, so I think this is a very good prediction. So again, to summarize this demo, I've showed you here how you can build up a more complex Kubeflow pipeline, and I also showed you how you can leverage the Amazon Sagemaker components for Kubeflow pipelines to integrate with the Amazon Sagemaker service and still maintain the single pane here in Kubeflow pipelines. All right, so to summarize, Kubeflow and Amazon Sagemaker deliver much value. Kubeflow, again, you can think of as the machine learning toolkit for Kubernetes, and it inherits much of the advantages from Kubernetes, such as the portability, the composability, the scalability, etc. And you can combine it with, for example, Amazon Sagemaker to tap into all of the additional capabilities that Sagemaker brings, for example, around the model training, managed spot training instances, automatic model tuning, or the model monitoring capabilities once you deploy the model in production. To get started, here are a couple of links for you. So first of all, the link to the demo code. Also, again, the link to the blog post, which discusses all of the contributions from AWS to the Kubeflow project. And then a couple of links for where to find the documentation, specifically Kubeflow on AWS, where to find the components for Kubeflow pipelines, and also a link to an EKS online workshop, which contains a section on Kubeflow if you want to have a look for yourself. And with that, I hope you enjoyed the session. Thanks for watching.